Who in the room would classify yourself as a .NET developer? Most of you. Java developers? Okay, JavaScript developers. Okay, some of you. Anybody in the room morally opposed to hand raising? Okay, I always get like one or two. Many of you probably are, you just don't know how to express it in the moment. Okay, so right, we kind of live in a world where you have to be more than one thing. Like I saw many people raise their hands for .NET and for JavaScript. Like you can't just do one thing anymore. And I cut myself off after Java. Any PHP? Some. You can be proud. PHP. Yo. I have live production code running in WordPress right now. It's been around for a while. So what about like Ruby? Yes, I've got a couple. Very proud. The Ruby developers are always very proud. Like I do Ruby. They're kind of like the Vim IDE users. Anybody code in VI, right? They will let you know even if you don't ask. So a friend of mine codes in VI and it comes up in conversation regularly about any topic at all. Where do you want to go for dinner? You know I code in VI. All right. Okay. Who in the room is using GraphQL right now? A couple. Okay. So the vast majority of this talk, I'm going to kind of set the tone for the talk, and you decide if you want to stay or if you don't want to stay, whatever, I don't care. So what I'm going to do is I've got a RESTful API. I'm going to lay a GraphQL layer on top of it. And then I'm going to show you how to do subscriptions, and then we're going to talk about wrapping in a function up on Azure. Like that's the talk. I'm going to talk a lot about just what GraphQL is, because you may have noticed a few of you raised your hand, most of you did not. And so that's about what I normally expect for this talk. Okay, but one thing to note, those of you who raised your hand that you do GraphQL today, I'm doing some live demo stuff, and so whenever it breaks, I saw you raise your hand, and you're on the hook to help me, figure it out. All right. So I'm John. I am from, if you haven't noticed already, America. And this is my second time at Build Stuff. So I assume I love this conference. You guys, those of you who are local, you have some fantastic community organizers who have put together a pretty awesome event. So thank you for having me in addition to like all the good people who are out there. Okay, who's heard of Star Wars? Right, so that's one thing that's always kind of fun, right? No matter where I am in the world, I can say Star Wars and everybody should know where I'm at. So there is a website called Swappy. And it took me longer than I would like to admit that it stands for the Star Wars API. But yeah, so there is a website out there called Swappy. That is the Star Wars API. And what the Star Wars API does is basically it's just a RESTful API. See down there, go to /people. It gives you a list of people. /people/1 gives you guess. Take a guess. Who people 1 gets you? Vader? Jeffrey Strauss, what does people /1 get you? I'm going to get you Luke. Luke Skywalker. No, it's the first person. Anyway, okay, right. And there's all this cool data. Now I am in a demo environment, and the first rule of a demo environment is never trust and rely on the internet. So I have not. So I've built my own, but I stole the data from here, so I have to give them credit. And I kind of want to show you what this looks like. So I have an API, a plain RESTful API, right? Get people, get planets, get films. It just does that kind of stuff. And if I open up the browser, to localhost 3000 films, look at what it gets me. A New Hope, it gets me the opening crawl, the episode ID, directors, the producers, etc. And then if I click on people 1, it gives me Luke Skywalker, and I've got all this stuff in here, right? Okay, so this is the API that I have, and this is the API we're going to be playing with over the course of this demo. Now here's the problem. Who uses RESTful APIs right now? RESTful APIs are cool. Don't get me wrong. I'm going to say some bad things about them. I use them. Like, just because things aren't all awesome doesn't mean none of it's awesome. So, this talk is about GraphQL. Right? And so we're going to kind of start with just a real quick basic why GraphQL. Right? Those of you who build RESTful APIs will agree with me most likely. There you go. That most websites look like this, right? We have a browser, a laptop, a desktop, or something else that's going to hit an API on the back end. How many of you do this every day? Like, this is write websites, iterate over arrays, pull data from a database. That's your job, like summed up in a small little bundle. But here's the reality in the world we kind of live in today. Now we have mobile devices that do native apps. Right? So I have a client where we're building a browser app, we're building a native app, maybe we have a watch app, and for some reason I cannot explain, we now have refrigerators that have their own app, in case you want to tweet something while you're getting something out of your refrigerator, right? Now here's the problem with this scenario. Is the data that the watch needs in shape the same as what the browser needs? It better not be, right? Because if you're putting all that data down here on the browser or on the watch, then you've got some performance issues, right? If you've got, if I wanted to display the film and the name of all the characters, if you remember I only showed it to you for a second, but if you remember what that API looks like, if you want to build a app that shows the film and the characters in that film, how many API calls do you have to make? Quite a few, right? Because you've got to iterate over all the characters in the film. Now, what some people will say is just fix your API. How many of you own both the front end and, like, you personally own the front end and the back end and can do whatever you want all across the board? It's fine. Quite a few people still do. A lot of us still don't. And you don't have to be ashamed of it. Like, it's okay to say, I own it all. But that's kind of the world we live in. And so what GraphQL does is it puts the power, there's a hole right here, by the way, just so we're all clear. If I fall down, I'll keep going, it's okay. What GraphQL allows us to do is start to decide as a consumer what the shape of my data looks like, what pieces of data, what pieces of sub-data I want to get, and as a consumer, I can just do whatever I want. So anybody want to take a quick guess what QL stands for? Query language, right? I'm going to write a query, and I'm going to go do this thing. It's going to be awesome. All right, so let's look at our Star Wars film real quick. If you recall, when you looked at it, you've got this, right? A New Hope, Episode 4, The Crawl, all of this stuff. If you're going to have a query, you also have to have a schema. And that's one of the cool benefits of GraphQL is, or horrible, painful points. It depends on who you are. But you have to now, as a JavaScript developer, this drives me nuts, I have to define every little thing about my API and about my data so that you know what to do and how to use it. So I take this and then I start identifying what these things are. So I have a title, an episode ID, an opening crawl, and I define them with a type, right? Now it's not .NET types, it's not JavaScript types, it's not Java types, it's its own special kind of thing, but there's only a couple of them, right? Int, float, string, boolean, ID. That's it. Objects. We'll get to those in a minute. But int, float, string, boolean, ID. So basically you take this, You say that, and now I have my schema. So I take that schema, and I say, here's what a film looks like. Then I take my query, and I say, hey, we have one thing we can do with this API. Get films. That's all you can do, and it's going to return what? An array of films. And then I even have to define, there's a lot here that I have to do. I have to define what I'm allowed to filter on. I'm allowed to filter on a director. I'm allowed to filter on the episode ID. That's all I'm allowed to filter on. Then we have this thing called resolvers. Last thing real quick. The resolver is actually what executes the query. I go write a bunch of code that says, hey, when you execute the query get films, I'm going to go out to my RESTful API to films. I'm going to filter my data based upon the arguments that you pass in, and that's it, and we're done. Okay, I am going to build this. I'm going very fast here because we're going to look at code and we're going to play around. I'm going to build this in Apollo. Who uses Apollo? Okay, I've got a couple of you. So you're going to help me with my demo. Deb, you're going to help me with my demo. Okay, we've got it. We're in sync. All right. The reason why I use Apollo as opposed to anything else, lots and lots of people use Apollo. This is a bad representation because we only had 2 or 3. But, and the documentation is fantastic and it's incredibly simple implementation. Incredibly simple implementation. So I'm going to walk through, I'm going to use Apollo as we do this, and we're going to go, okay, let's look at code. Because that's the part that matters. All right, real quick. In my app.js file, I have an Apollo server with my type definitions and my resolvers. I've got my schema. Look at this. What does my schema say? My schema says I have a film. My schema says I have a query. Get films. And that's it. Director, episode ID. And then my resolver is going to go do some stuff. Now I'm going to run this. All right, let's play around a little bit. When I come here, I don't want that. Nope. When I come here, if you go hit a RESTful API for the first time ever, how do you know what you can do? It's kind of a trick question because you can't, right? I mean, unless they document it really well. Now, writing docs, there's several talks on writing docs. Write some docs. Those are important. However, wouldn't it be awesome if the first time I hit an API, I can have docs that are already built that tell me, do what? Swagger's pretty great. Yep. But here I have, without writing any code to do it, I have docs that says, hey, I can execute a query called get films that's going to return a type of film, and here's all the stuff that I can pull out of that. Right? I have all my schemas right here. Everything's built in. And then we do this. Okay. So I say query. What query am I executing? Get films. And then what do you want to see? What information do you want to see? Title. Title makes a lot of sense. If you're paying attention, what are you noticing? This came out of the box in Apollo, this little editor that I have right here. You can turn it off, but I don't turn it off for development for obvious reasons. It's got IntelliSense, which is fantastic. Okay, I'm going to run this. And look at that. Get films, A New Hope, George Lucas. That's all. But I can define the stuff that I want. And that's the easy part. That's easy. What if who's your favorite Star Wars director? Let's be clear about this real quick. There is no, I'm not even going to take answers because there's only one. So here I have the others, and I have George Lucas. Now I just have the George Lucases, right? Okay. So this is pretty simple and straightforward. And those of you who use GraphQL already, you know this already. This is super easy. But it took very little code to make this thing happen. The beauty of GraphQL comes not when I have one thing, right? I have films. I can just hit /films. I probably have a filter on that. That's fine, whatever. When I start wanting to do, remember I had characters. I don't have characters yet because I don't have that code. But when I want to start having the subtypes, the sub-objects. Okay, because remember, a film didn't look like this in my RESTful API. A film looked like this. I had characters and planets and starships and all of these things, and my RESTful API it's got to pick through all the ones that I want. Like characters, I've got 81 of them. I don't have 81 of them. In this particular movie, I just have a lot of them. And so what you end up doing is you end up adding those to your schema and building out new things. So characters are an array of people. Planets are an array of planets, so on and so forth. This bracket right here means array, very importantly. Because a person looks like this. Homeworld is a planet, but it's only a single planet. It's not an array of planets, so I can have a type of object just like that. All right, how do you do this? Sub-revolvers are pretty straightforward. You end up with a whole lot of stuff that looks like this. This is small, and you in the back can't read it, so I'm going to make it bigger. It's going to look like this, right? So you have a film. Remember, I had query, get films, and I just put my resolver in there. Now, in the context of film, I have a planets resolver. And in the context of film, my planets resolver is passed in a film, and then it just goes and pulls the list of planets and filters those based upon whatever is in my films. And then I end up with a lot of them. I've got a planets resolver, a characters resolver, a starships resolver, and so on and so forth. So what you end up with is this. Now I have, let's go real quick to my schema. Look, I've got my film, I've got my planet, my people, my starships, my vehicles, all of that stuff is all now defined. Still only my get films. My resolver, now I have this film with characters in it. So I can go get people. Let's run this, and then I want to show you something else. So if I go into my node app.js and I pull this up and I hit the same thing again, I got to refresh, and I run that, we've added people, right? We want to see everybody's name. So in A New Hope, you have Luke Skywalker, C-3PO, R2-D2, Darth Vader, so on and so forth. Over on my other screen, I had my when I run this, how many times did I go get people? 4 times. Why did I go get people 4 times? Because I had 4 films, right? So when it goes against the films, and then for each film, it goes and makes an API call to people to go and get a whole bunch of more stuff. If I only had the one, it would only do it once. I'm still making the same RESTful API calls that I would if I was on the browser on the front end. Why is this better? There's a big difference between making multiple API calls from your backend server to a backend server than it is from the browser to the backend server. Right, and so yes, I'm still making the same API calls to my RESTful API, but instead of making them across the wire from my browser or my watch all the way back to my RESTful API in my JavaScript application, now I'm doing it all from the back end, which makes a huge difference. But what happens when I now want to say, hey, not that. What happens when I want to go get their planet? Like I want to get their homeworld. That's not going to work because I don't have my resolver yet. But I kind of keep going, and this actually continues to get slightly worse. Because now, what do we have to do to make this happen? So I have my film that's going to go pull characters. I now have to create another resolver in the context of people, right? And that's going to and it's people with a resolver of type planet. That's going to make this stuff happen. Now notice, do people have planets or do people have homeworlds? Homeworld, singular. They have one homeworld. So, hey, when you go get homeworld, my people resolver is going to do, and what's it going to do? It's going to go hit planets. That's unfortunate, because now what's going to happen? Tatooine. Is C-3PO's homeworld really Tatooine? Yes, it is. We agree on that. Okay. I didn't really pay attention too much once I got to those later movies because they weren't super awesome. If you like them a lot, I'm sorry. I'm sorry that you like them. I'm sorry that I'm probably being offensive to you. But that's okay. But look here. This now is a problem. Because I went and hit planets a whole bunch of times. And I'm making the same API call over and over again because it's like a lot. I hit films, people a couple of times, and then planets. For every film, for every person, I went and hit planets again. And so that's less than ideal. And so what we actually want to do, this is where, okay. I had a client who we wanted to use GraphQL because we had something that was similar to this situation, right? We've got multiple things that want to hit the same API. The API kind of existed already. We want to hit, we want to set a GraphQL layer on top of it to kind of do it. And they went out on the internet and did a Google search for GraphQL. Do you know what the first 4 results they found when they did it? GraphQL performance problems. GraphQL performance is terrible. It's horrible, all of these things. And they said, well, we did a Google search. This is a literal conversation that happened between our team and the CTO of a very large organization. The CTO said, I did a Google search on GraphQL and the performance is bad, so you can't use it. Okay, so the reason why one of the reasons, there's a lot of reasons, but one of the reasons why you get bad performance is you end up doing ridiculous things like this and you don't pay attention, you don't really think about it. And so what we want to kind of get into as we start to walk through that, I did Homeworld, I did the sub-resolvers, is using data loaders. Those of you who use GraphQL today, do you do any kind of data caching or something like that to prevent the multiple queries on a resolver? With Apollo, this stuff comes built in, which is kind of awesome, and I like it a lot. And so what Apollo will do for you is it'll call that planets, And anytime that request needs to call that API again, it just returns the same result over and over again. If a different request needs to go call an API, out of the box it won't do it. You can cache the data, you can do whatever you want, but out of the box, Apollo gives you kind of that fun thing. And it does that this way. So we have this thing called a data source. Apollo data source REST. There are lots of these. There's Apollo data source MongoDB. There's Apollo data source Redis. I mean, there's a whole bunch of different ones that exist out there. But just out of the box, I say, hey, Apollo data source REST, check this out. My base URL is this, and I create functions that just go and get the APIs. Now, it'll pass IDs. It'll do all that stuff too for you. But for the purposes of demo, I left it as simple as I could just to explain. But here we go. I now have this data source. My resolvers now look like this. So they used to look like this, right? Where it was axios.get, I was pulling films, then I had it then, it was promises, it was all terrible, and I didn't like any of it. Now they look like this. I just pull my data sources from my context, my Star Wars API, get films, I now have films. And everything just kind of works out of the box. And so now, when I do just so you believe me, hold on. Let me clear my screen. When I hit go, now I just made 3 API calls instead of a whole bunch of them. Down here, just the 3, right? Because it made, instead of making, it always made 1, but it made 4 calls to people. So now it doesn't do that anymore. And then it made however many calls to planets, and now it just makes the 1, and it caches it, and it does it over again. All right. So if I go through that, that's the easy part, right? That's selecting data and going out and you're pulling data and you're just, building out a simple application that displays stuff. How many of you get away with only ever displaying data and you never have to change anything and you don't have to take user input? Or anybody? Does anybody get to live in that world? I do not. And so what we end up doing is, so in the RESTful world, what do you do to change data? How does REST do this? Patch. Yup. Put, post. Patch is my favorite. I like that. I like the fact that you said patch first because a lot of people don't implement that, and it makes me very sad. Or they don't do it properly. I'm not going to talk about that because I don't want to go sideways, but correct. So REST is very verb-based, right? So I have get to go get data. I have post to add data. I have put to change data or patch to change data. But they're not always implemented that way. Anyway, so back to in GraphQL, we have queries and we have mutations. And what mutations do is modify data. That's their whole job, right? And so, same thing. Remember, I have a type of query and I have a type of mutation. And then I go in, same way, and I just say, hey, I can change the population of a planet. Or I can add a new planet. Or I can add a character. Or I can add a film. And then I say, hey, here's what you pass in. Now you can pass in objects or you can pass in types. You can do kind of what you want here. But that's how that works. And then you go and you build a mutation. So in the case of change population, I have to go and find my planet, and then I have to alter the population of said planet. All right, so for the purposes of this, I'm actually going to kill that one, because now we're going to start like changing data and playing around a lot, and I'm going to do this differently. Same basic idea, just slightly different. Where's my mutation? Here's my mutation. So change population, I'm going to go change it and go from there. I also have added a new query called getPlanets. Because now, if it doesn't make any sense to change the population of a planet if I can't go and get a planet. So let's do that real quick. Refresh. All right. How would I do that? I just do get planets, and I want the name of the planet. Boom. Oh, and I want the population of the planet. Yep. And that's it. So my mutations are going to be kind of the same thing. And the cool thing about it is you all kind of wrap it together. I come over to my docs. I say, hey, I have a change population. That's how that works. So I'm going to come back over here, and I'm just going to do mutation. I'm going to do change population. Who do we want to mess with? Let's change the population of what do I want to change? Who do I want to change the population of? You're going right to it. In fairness, they only did blow up one planet, right? I mean, they could have blown up a lot more. They only did one. 0 would have been better. In fairness, yes, 0 is a better option of planets to destroy than 1. Does the Death Star count as a planet? No, because then the rebels actually didn't destroy any planets. They just destroyed a small moon. Oh, okay. So here's the thing. Here's what I did. Change population 3000 URL 4. And I get an error. Field change population of type planet must has a selection of subfields. Because a mutation works just the same way as a query. Like, I'm going to go change something, but then at the same time, I have to say I want the name of the planet. I have to say I want the, what do I want? Population, so I make sure that it worked. And I want the URL, the ID of that planet. Is this going to work when I run it? Oh, you can't see it. There's a little red thing right here that says this is horribly broken. It gives me a nice error. I have to... Oh, that's right. For some reason, who has ever worked with a stupid API? One more thing I have to change. Hold, please. For some reason, the population of a planet is a string, if that makes sense. I can hear the camera clicking as I'm fixing my broken demo, and that's super awesome. Okay. There we go. I have successfully changed the population of the planet Hoth, because I'm not going to go there quite yet, to 30,000, right? And that's kind of how mutations work, right? I just change population, I pass it in, go like that, and now everything's going the same way. And then I can come over here and I can just do query, get planets, name, population, boom, there we go. Now, one thing to point out, and I kind of glossed over this, I'll come back to it. If I change this to that, I get errors, and it actually will do validation for me, right? So wouldn't it be cool if you're doing just a basic REST API call and like it did type validation on all of your parameters and all that kind of stuff? So that's built in. The fact that you have a schema and you define everything up front, which is, I know as a JavaScript developer sounds weird, because the last thing in the world I want to do is define everything up front, but that's what we do, makes me have cool stuff like this, where I can say, okay, here's why it's broken, and here's why I want to go with it. All right. Now, we've made it through the normal stuff. And you guys might be saying, well, if I recall properly, the name of this talk is building real-time serverless APIs, not building like simple APIs. So how many of you have ever had to write a front end where if the data changes on the back end, you need to let your user update the screen? Well, how do you do that? You poll over and over again. Or you do that, which is spoiler. So yes, give me a second and we'll get there. But right, so I have written heartbeat queries or polling queries that just says, hey, every 30 seconds, go and ping. That doesn't scale super well. If you have, hundreds of thousands of users all long polling the backend API to see if their message has come through yet, you don't want to do that. So what GraphQL does using WebSockets is this idea of subscriptions. So I have mutations, I have queries. Well, I also have this thing called subscriptions. And what subscriptions will do for me is it will allow me to request some data, and then every time that data changes, it's going to push that resulting data change out to everybody who's subscribed using WebSockets. So again, same way as before, we have type query, we have type mutation, we have type subscription, and I'm going to watch for changes in planets. Right? If a planet changes, I want a subscription notification that says, hey, this planet changed, and okay, that's awesome. And we use this thing called pub/sub, those things I was commenting out just a second ago, because my demo was broken, and we'll fix it. And so basically, we have this subscription model that says, hey, a subscription is going to subscribe to a specific channel, planet changed, and every time somebody changes a planet, I'm going to publish to it. And then it's going to go and push that data out to everybody. All right. So I'm going to uncomment these. Okay, right? I've got planets change my query. I've got pub/sub up here. When I subscribe to something, I am subscribing to Planets Changed. So when a subscription is done, it just subscribes to something. When a population on a planet changes, what does it do? It just publishes the changed planet. And that's all you have to do. And so, real quick, I'm going to do that, and it's going to, all right. Address in use. I don't even know how that's possible. It's Node. Thanks for that. There we go. Yay! When in doubt, turn it off, turn it back on again, because you all know that that's all I did. There we go. Okay. So I changed the population of Hoth to 3,000. I changed the population of Hoth to 30,000. There it goes. I'm going to pull this in like this. And I am going to add another one, localhost 4,000. And I'm going to, instead of a mutation, I'm going to do a subscription. And I'm going to subscribe to Planet Changed. And I want the name, I want the population, and I want the URL. And I'm going to hit go. And it's going to just sit there and listen. And it's not going to do anything. But when I come over here and I change my population of Hoth to a lot, notice all of a sudden, on its own, it pulled up the new data. So WebSockets, it's just pushing. And it was 4 lines of code to make that happen. It just does it with PubSub and all that. Now, you can have more mutations. You can have lots of them. And so so when the Death Star does finally get there, right, so now, down here at the bottom, it's now called Asteroid Belt, which is very unfortunate. Okay, so that's subscriptions, right? So the whole, I gave this talk on Monday, and somebody came up to me afterwards and said, well, I don't have any, real-time updates, and I own the API. So why should I switch? I said, are you just a browser or just a web app? And he's like, yes. That you shouldn't. Like, it doesn't make any sense for you to do that because you're not going to take advantage of any of the benefits of this. Most of the time, the advantage to GraphQL and where you want to start using it is in 3 scenarios. One, if you don't control the API and you want to push some of this querying to the back end, GraphQL is a great option. If you need the real-time updates, which was a scenario we had. There are other ways to do WebSockets, absolutely, but they're baked into GraphQL. There's a standard for them, and that's super awesome. And right, so that's kind of where you want to go, right? Is if you're in kind of those scenarios, then that's where you want to start doing it. The beauty of Apollo is that you also, and who uses Azure? Azure out of the box today? You guys are not in sync at all. Who uses Azure today? Okay, excellent. AWS? Okay. Oh, that was actually pretty even. Usually I get far more AWS than I do Azure, unless I am at a .NET conference. And if I'm at a .NET conference, everybody uses Azure, and they're like, what's AWS? I haven't heard of that before. Even though AWS owns like 90%. But out of the box, Apollo gives us Azure Function support. Who uses Azure Functions? Right, so native Azure things instead of going in and just keeping your application as it is in a container and just pushing it up. Like, use the native Azure stuff. And what Apollo does out of the box is actually just allows us, instead of pulling in Azure Server or Apollo Server, I just pull in Apollo Server function and do the same thing. My type defs, my resolvers, my data sources, everything just works. I changed nothing except I set up a new function, and now instead of node start, you can do this func host start, and everything just works. And now I'm wrapped in an Azure function and I can push it up. So you can build your whole GraphQL API, make it all work and it's super awesome, and then wrap that in an Azure function and deploy it up to Azure, and it all just works. So, all right. I answered the question and I didn't even see that it happened. So I have, the question is, are there scenarios where you would recommend to use REST instead of GraphQL? Yes. Who asked that question? And did I answer the question? Nobody wants to admit they asked the question? It was a really good, legitimate question. Right, because again, I want to be kind of clear with this. Just like we have .NET, and we have JavaScript, and we have all these other things, and we have different tools that kind of go in the toolbox. If you're doing a standard API that you just go pull data and you change data and it's used by one source and that's all, and REST is great. REST is a standard that everybody uses. It's fine. Most of the APIs on the internet are REST. When you start to hit the scenarios where you have multiple things, or the third, remember I said three, but then I only told you two. The third reason why you use GraphQL, and this is where we use it quite a bit. I have multiple disparate systems, and I need to aggregate data from all of those systems and then push that data back up to a browser or an app. That's another great scenario for GraphQL. But if you're doing a basic API, REST API works just fine. If you also want the discoverability, the schema and all of that stuff, that's where GraphQL comes in pretty well. All right, so if you have questions, let me know. Like, you can come up and we can chat about it. I'm at time almost, so I don't want to like hold everybody. But if you have questions, come let me know. Otherwise, the whole point of this talk is to take a whole bunch of, usually none of you had done GraphQL before. Like, GraphQL is not hard. It actually works pretty well, and Apollo docs are phenomenal. So take a little bit of time, go look at the Apollo docs, and play around with it. And you will love it very, very quickly. So, all right, thank you guys very much. If you have questions, come up and see me.